Welcome back to some more Black Hat Python. We have finally finished this recapper program here. And let me just say, this has definitely been the most ambitious project we've done yet. This one can be quite confusing. It took me a while to really make sense of the code, but I am going to do my best to explain it in an easy way to understand, because if we go line by line, it's really not that hard to understand. And I'll show you a trick as well if you stay tuned to the video on how you can figure out some of these really difficult parts that you might not know what's going on. There's a really cool trick that I definitely made use of that helped a lot. And I actually learned a lot about Python just by writing and trying to understand this script here. What's up, guys? This is Ryan from elevatecyber. Now, if we remember from the last video in this series, we were creating this recapper file here. Basically, what it's going to do, this Python script will take in a pcap file and strip out any of the images in that capture. So the Black Hat Python didn't really supply us with any sample pcap files, so I created my own. The way I did that, if you want to reproduce, is that I found some random HTTP site. In this case, I'm using apimages.com because it's not going to be behind SSL. And I just clicked around while here I just said, start a capture. I clicked this button here to start capturing my traffic. And I just clicked around randomly through the site. And I got some images. Obviously, there's images on this site. So when I'm browsing around, any of the images from the HTTP request is going to be captured and a part of that pcap file. And it looks something like this when it was all said and done. I just went to a few images, grabbed them, right? So amongst all of our traffic here, we have these HTTP requests and the files and all of that stuff. That's what we're really going to be making use of, as you'll see here in a second. Now, in the previous video, I went over the outline, the skeleton outline. Now everything's actually populated. So let's just go line by line and try to make sense of this. This might be a bit of a lengthy explanation here, but I want to make sure you guys get it, right? So this is where the file starts, right? Because it says, okay, you ran the script, so therefore name is equal to main. So let's just run this line by line, right? So it's going to do an OS path join on pcaps. Pcap.pcap is the file. So in this case, we're just hard coding the name of the pcap file that we're going to use. So whichever pcap file you're going to use, make sure you save it as pcap.pcap. And it'll be looking in this pcaps directory here for the file. I put it in my downloads, and it'll be joining the path with the file name and setting it to the pfile variable. And this one I just did for debugging purposes, actually. I can get rid of that print statement. The next thing we're going to want to do is call the recapper class, passing in pfile into the init function, right? Because that's what's going to run when you just call the class, right, is the init function. So our initialization function is going to take in that pcap file name, and it's going to run rdpcap, which is something that we imported, which is short for read pcap. I looked that one up when I was researching this. So all this thing is going to do is part of Scapy, and it's going to allow you to read the pcap file quite simply. And upon doing that, it will assign that to the pcap variable. And we're going to be defining a few more variables, self.sessions, so we can use this elsewhere in the class, the sessions variable. And that will be running the sessions method on the pcap file. And then we're going to be initializing a variable of a list type called response, which we're going to append to a little bit later on. So that's all that happens in line 78. Now in line 79, that's all that happens in line 79. Now in line 80, we're going to actually refer to the instance of the class that we defined here, and we're going to run the getResponses method. So this is getResponses here, and it's going to iterate through all of these sessions that we got when we ran sessions on our pcap file. And for each session, we're going to initialize a payload, and we're going to actually look at each item in self.sessions session. So each session has like a number of items in them as well as a list that we can iterate through, and we're going to assign that to the packet variable. And so if the destination port or the source port of the packet in self session is equal to port 80, then we will append the byte string to the payload. So if that was a bit much to swallow, basically what we're doing here is we're looking at the packets to see what is port 80, right? Because the port 80 stuff is going to be our HTTP traffic, right? That's the only stuff that we're, first of all, interested in. So if we find any of that stuff, we're going to append it to this payload variable. Now, we want that in bytes, and you'll see why in a little bit. But when we grab it like this, I believe it's a string, packet TCP payload. So we will typecast that into bytes using this bytes function right here built into Python. And then once we run out of index, we can just write X and flush. So basically this is like a print statement here. That's all this is doing, printing X's to the screen if we hit the index error. And then we're going to look if there's any payloads that were written at all. And if so, then we will attempt to grab the headers of those payloads. So if we did get anything for port 80, if we found anything in the port 80, it would have appended to the payload. Therefore, there would be something in payload. And then we would call the getHeader function passing in that payload. And so if we look up to the getHeader function at the top here, we will see that it takes in the payload. And now this is just basically doing some magic here to grab the raw header. Basically what this means when you see a list index start with the colon, that means anything from the beginning up until this point, payload.index, and then this byte string. So anything up to carriage return line feed plus 2 is what we're going to actually end up stripping out of this, and we'll set that to the raw header. And so if we do get some kind of value error, then we'll just write a dash to the console and return none, meaning there was no header for that we could grab. And once we have these headers, here's where I used a trick that I am going to talk to here. So if you've watched to this point, here's where some real gold is, I believe, in my opinion at least, is that this could be a little bit difficult to digest. This regular expression here, like what the heck's going on? I had to do some Googling here to figure out, because they didn't tell you in the book, so they assumed you knew, so I just had to Google it. No big deal, right? What does this mean in a regular expression? Well, this is basically creating a named group in Python. And so this name here, it doesn't have to be name and value. This is just what we're naming this regex group. I could call it, Falarf and Pizza123 if I wanted to. But basically here, I have defined a group called name and a group called value. And this group is going to be equal to $*, which I also didn't realize, I didn't know what was the difference between $* and $*? And just a simple Google search allowed me to find out that this means the non-greedy wildcard here. So I would Google greedy versus non-greedy regular expressions if you're not sure what that means. I don't want this video to drag on too long, so I'm not going to go into every little detail here, but that's what I would Google for if you don't know what a non-greedy regular expression is, or non-greedy wildcard, I should say. So basically, I'm looking for anything non-greedy up until a colon, and then anything up until carriage return line feed. And I was confused at first, and we're going to look through the raw header decoded. And what I was confused about is I'm used to, something like this just returning one value, but if you're actually using these name groups here, it's going to return 2 values. And this is how I determine this, and this is the trick that I was talking about. What you can do, and I knew I could do this, I just don't make enough use of this, is you can actually use what Python has called a Python interpreter, the built-in interpreter, and we can see what these values are going to kind of look like, right? So let's say I define a variable called header raw. And let's just say that its value is, this is a raw header, right? So just a string like that, we'll just say a byte string, though, that's important. This is we'll say this is a byte string, right? This is a byte string. So let's say that my byte string is equal to this, right? So what is that going to look like? That's going to look like that, right? It's a byte string, but we can actually call header raw .decode on that. And if we do that, then we'll just see the decoded string. So if I wanted to run this regular expression, right, I could import RE, and then I could say, just what they had there, but accounting for our situation. So I could do an RE find all, and I could create a name group that I'll call name1, or I'll just call it group name 1. And we can say that we want to look for, the non-greedy operator here up until this other name group of the word byte, we'll just say. So we'll call this group name 2, and we'll just say the string there, byte. And we want to run that against header raw.decode, right, the string. So we got to run that against a string. That's how refindAll works. And let's see here. We forgot to close out the single quote, so we'll do that there. And then this is what it's going to look like, right? So this is a byte, right? So it actually returns a comma-separated list here. Oh, comma-separated value inside of a list, right? So this is what it's actually going to look like. So if I just go ahead, so basically this is how you could set a dictionary. This is the perfect format if you declare a dictionary. And one way, there's multiple ways to declare a dictionary. One way is to actually just give it like the square bracket comma form like this for key value, right? So if I said my key, comma, my value, and close that out. And let's just say test dictionary is going to be equal to that, right? So if I print that off, see, that is one way that you can declare a dictionary, right? You can initialize a dictionary. So what we're going to do is just use this refindAll to initialize our dictionary, right? So that's basically what the code is doing. And we just figured that out by going step by step in the interpreter, right? So I can type it like that, and I'll assign this to a dictionary that as the key, and then this has the value. So that was just in the case of our example, right? So in there is what they're doing is they're making the headers, right? So if you're familiar with headers, if you're not, let me pull up. I got the tab here. Let me just open it up in. We'll open it up here. So these are what headers look like, just sort of jog your memory, right? You have what you could essentially call the key here, and then a colon, right? And that's why we have this colon here. And then the value is this part. Well, this whole part, right? Everything else up until carriage return line feed, which carriage return line feed would be right after this 8 in this case. Oops, not sure what I clicked on there. But yeah, now you can probably see how this is forming together. That's just basically how we're using regular expressions to grab our header and build a dictionary out of it. Pretty cool stuff, really. And what we're concerned about is, okay, are one of the content types keys equal to the name content, or sorry, are one of the headers keys equal to the string content type? We want to have that header. If that header doesn't exist in any of the headers that we construct here, then we're just going to return none. We're not going to worry about it. But if content type does exist as a header, we're going to return the header dictionary then, because that is one that we're potentially interested in. So going back to the function that called getHeader, we can see that, let's just assume that we were able to get one with content type or return the header. Then the header variable is now equal to that header value, which is the dictionary, right? And so as long as we got something for header, then we're going to go ahead and do the append here, right? And I mean, if we continue, it's not really going to append. It's not going to really write any data here. So it will do a self responses append response header equals the header value, right? oops, right here. Yep, header value. And then payload is going to be equal to the payload here. So that is just going to append to that responses array, or list, I should say, that we declared up here. We're just going to keep on appending to that. And it's just going to be a simple list. And it's going to have, if you want to know what that looks like, we can once again break that down with the Python interpreter. That's why this thing is awesome. If you're ever not sure what some code does, just start writing some of it and you can see, right? Let's say we define responses as a list, right? So now let's just say we have header equal to header in this case. It would really be actual data, right? But we're just going to use these strings as placeholder values, right? So then what we could do is something like responses.append, right? Just exactly as we see it written in the code, responses.append. And oh yeah, let's define response. I'm just going to copy paste that line. It's kind of long. This one here. Let's import collections, right? Because we need the collections library for this. But I'm just showing you how I break this down step by step. So we'll import collections, and then we'll define response. And then we'll come back down to that code that we're looking at. Let's see, where was that? I believe it was down here. Yep, right here. So now I can just append to that list, right? And so now if I check responses, I'll see that. And if let's say I change I have a different header, right? It's because it's going to keep doing this iteratively, right? Let's say header 2 and payload equal to payload 2. Let me add the single quotes in there. So now if I run this again with the append, I could check responses. And now, yep, see, it's just a simple list of these values here. That's all it is. I know it looks kind of crazy, but all it is a simple list. Now, and if you were confused about what the data type was, you could say type responses, right? So if you're ever unclear, you can see, hey, this is just a list. And if you want to see type of responses, like each index, right, you can see class main.responses, right? So you got this class here, class list, class main.responses. So what we can do is, since it is a list, we can iterate through that, as you'll see in a minute, right? So the get responses stuff ended. It didn't return anything. The only purpose of get responses was to append to this responses list here. Keep appending header payload of the response named tuple, which we talked about before, the named tuple. And check out the previous video in this series if you are unclear on that. But yeah, we're going to do that, and that is it for line 80. Quite a bit going on in line 80, right? So then it's going to go to line 81, and it's going to do a recapper.write, passing in this hard-coded keyword here, image. And that's because we want to find image files. And you'll see in a minute why. I'll explain in a minute why that is. So it will be calling the write method of the recapper class, which is right here. And this image is going to be passed in as content name, the content name variable. And we are going to actually loop through, even though self.responses is a list, we're going to actually iterate through it using both I and the word response. And what that's going to allow us to do is it's actually going to allow us to get both the index as a usable variable as well as the value. Right? So I'll show you guys just what this means. I don't care if this video goes a little long. I want to make sure that you guys know what's going on. Because let's say I have a list called my list, right? And we'll just hard code some values in here. We'll say this is my list, right? So we just have a list, right? Now, the way that you would normally think to loop through this would be for word, or, for item in list, or whatever you want to call it, right? For item in my list, print item, right? That's the way that we typically loop through one of these things, and we would get that, right? Well, there's another way that you can actually iterate through this list. Instead of that, you could say for item, for example, in my list. And now let's say if I wanted to print both, just so you can see what's happening, I can now access the index variable as well. Oops. Oh, in enumerate, my bad. So when you do it this way, you got to say for I item in enumerate my list. And you want to enclose that in parentheses. So sorry about the little type error there. So we do that, print item as well. And now you can see, look, not only do we have access to the values at each index, but we also have access to the actual, which index it is, right? So 0, 1, 2, 3. So it'll be apparent in a minute why they chose to write it this way. So what we can see here is, we're going to, loop through that, and we're going to define two variables here, both content and content type. And now we're going to call the extract content function, passing in response, which, remember, response, all that is basically item, right? So it's the values here. That's what response is that we're passing in. And then content name is image, right? From here, image content name. So we pass both of those values into extract content, which is right here. And we're setting a default value for image just in case that wasn't specified. But from there, we're just going to initialize content and content type to none. And this response, don't get confused by that. All that is this response here, which, like I said, is the values from the list. And so going back to that, we see that if content name is in response header content type, then what we're going to do is just set the content type and set the content. So what that's doing, right? Because these are your headers, right? I already showed you guys basically the headers, what they look like will be something like this, right? Content type. Now, if you noticed here, these are, let's see, I might even have a better one to show this off. But if you have like images in your headers, right? Typically what you would see here's like text HTML. But if you had an image, right? Oh yeah, right here. You would see something like this, image / and then the image type, right? Could be JPEG, could be, here, let me make this bigger for you guys so you can see it. So this is what the header will actually look like. Content type, image / then the file type, right? So it could be PNG, JPEG, JPG, whatever it is, right? We want to get anything that's an image, right? So that is the precise reason that we declared image down here, because we want to look through these headers in the content type, specifically the content type header, and we want to grab anything after the /. Now, what is the /? The / is this / here. So if we do a built-in splits method on this, what we can do is say, hey, split on this. And so index 0 is just the word image, which we're not concerned with. Of course, it's going to say image. We want index 1, which is just going to be this JPEG here or PNG or whatever it happened to be. That is the part we want to grab so we can name the file appropriately, right? So that is the exact reason why we're calling a split on this and saying, hey, get us index 1, get us everything after the / and send that to content, set that to the content type variable. So that's why we do that. And then the actual content is going to be, of course, of interest to us. So we'll do a response.payload and just get the bytes data of this, because this is going to be all binary data because it's going to be images. If you ever tried to cat a JPEG file, it's going to be all of that garbled binary data. That's what we're grabbing here using the .payload here. And so after we do that, we're going to check if any encoding has been applied to it, because a lot of times so that you can transfer this around the net and nothing gets messed up in translation. There's going to be some coding to protect the data integrity. So you're going to see if there's content encoding. If there is, that will be a header in the response called content encoding. So if that exists, we're going to check if it's equal to gzip or if it's equal to deflate. If it is gzipped encoded, then we will use this one here, this specific one, which you don't have to you look into this too much. You can just know, okay, gzip, this is what I use. You could always Google it, right? And else, it's a little bit easier. Right? If it's the deflate, then all you need to do is decompress response.payload. And so after we extract it, we're going to, and assign all these variables, we're going to particularly want to return the content, right? That way we can write it to a file, and the content type. That way we can write the correct extension. So after we do that, we can go back to our write function here. And I can delete this line as well. That's for debugging purposes. So after all of that, we return those values and assign them to these two variables respectively. And now we're going to iterate through, we're not going to iterate through anything. I'm sorry here. We're going to actually make sure that we have both content and content type. If we have both of those things, then we can start creating our files. So our file name, we're going to set equal to our output directory joined with the actual name, right? So for each name, we're going to write ex underscore and whatever iteration we are through this loop here. That is why we decided to grab the index. That way we can uniquely name each file, so we're not overriding the files, because we wouldn't want to do that, right? So we'll just have them save as the ex underscore I dot content type, and content type will be like, JPEG or PNG. So it'll be like ex underscore some number dot JPEG or PNG or whatever the image file type was. That's why we extracted it in that way with splits and all that, or with split on slash, right? So the out directory is just like the directory where we want to have it output our files to. In my case, I just said, hey, put it in Kali desktop pictures. And I'll demo this here in a second. So we're just going to do that to write all the files, and we'll just have a little print statement to let the user know that it's writing the file. And then here's where the actual file write happens, right? Yep, open the file name, f.write content, and that is it. So if everything checks out well, then it will be able to parse this PCAP file here, where I log traffic going around the site here, grabbing images. It'll be able to extract only the images from the PCAP file, write them to their own file names, whatever file type they are, in our home Kali desktop, or documents pictures, I believe. Let's see. No, home Kali desktop pictures. That's where it should write it. So yeah, let's see if that works properly by demoing it here. So I'm just going to run this sudo for good measure. And there we go. If everything works, what you're going to see is it's writing. And you see that, we got a .jpeg, a .gif, PNG, a couple more GIFs. And let's go ahead and check that directory. So we'll look here, and we see that we got some files. So we can actually view the images. So it did, in fact, work successfully here. So that's pretty cool stuff for sure. I'm not sure how well these GIFs are going to work. You might need a little bit extra code to get GIFs working. Maybe something to look into if you're interested. But yeah, it looks like the GIFs got messed up. But everything else works properly. All the images. Let's see, what was the file type on that one? This PNG got a little bit screwed up here. Some errors. So this is extracting JPEGs just fine, but yeah, maybe something to look at to expand the code that they wrote in the book, if that's something you're interested in. But I'm not going to worry about that for now, at least. In the next video, though, we're going to be using OpenCV to identify faces in images, so that's going to be definitely a pretty interesting thing here. And I know this video was super long, but I really want to make sure that I explained every bit of code that was written here. And if there's any questions, be sure to let me know. I spent a lot of time going over this code and really making sense of it. So if there's something that you're not understanding, let me know. Perhaps I can clear it up in a future video or just by writing to you in the comments. And yeah, if you want to catch up on this series, go ahead and check out the videos on screen now. Be sure to subscribe, hit the like button as well if you haven't already. And I'll see you guys right over in those videos. Thanks for watching.